Excellent. All right. So hello, everyone. Yes, my name is Bruce Silver, and I want to talk to you today about the value of standards, in particular, the three business automation standards, BPMN, CMMN, and DMN, at the heart of the Flowable platform. If you've ever heard my name, it's likely through my method and style books, which aim to teach business users how to use those standards effectively. The specs from those standards were written for tool vendors, not for end users, and they avoid discussion of methodology, best practices, things that end users absolutely need, in addition to the rules of the specs. So I called mine method and style, and they're described in the books. All right, so the standards, BPMN, CMMN, and DMN, are managed by the Object Management Group, or OMG. And we'll talk about what those standards are, what they do, how we got them, the key principles behind them, and, of course, their business benefits. And finally, we'll discuss how AI, specifically the new generation of generative AI, is now adding value to them. All right, so in the beginning, let's say the year 2000, there were no standards, not for business automation, not for almost anything in tech, really. The web changed all that. I first heard about BPMN in 2003. I had been working in something called workflow automation, controlling the flow of human tasks, for over a dozen years, first as an engineering manager and then as an industry analyst. But suddenly, there was this new thing called BPM that I knew nothing about. Previously, in addition to workflow, there had been a completely separate technology called Enterprise Application Enterprise Application Integration, or EAI. It was also a process automation technology, but based on a message bus, system to system only, no human tasks. Both workflow and EAI software were proprietary. There were no standards. It was a real mess. There we go. Now, suddenly, a new technology called web services offered the possibility to unify them based on the standards of the World Wide Web. A Silicon Valley startup called Intalio did just that, using web services to define a new process automation language called BPML that unified workflow and application integration. Not only that, but solutions using this language would be defined not using code, but graphically, diagrams, using a diagram notation they called BPMN. This offered the hope of bridging the business IT divide that previously made workflow automation projects likely to fail. Enterprise application software vendors like SAP and Oracle liked it too. Functionality that previously was embedded in their monolithic applications now could be split off into microservices that could be invoked as needed and sequenced using the protocols of the World Wide Web. And this was a game changer. To maximize its appeal to business, BPMN took on the look of swim lane flowcharts, which were already widely used. And now BPMN promised what you draw is what you execute, which excited application software vendors who are always looking to engage the business side in support of their projects. So Intalio was able to organize a consortium of over 200 software companies called bpmi.org in support of this new idea. But In fact, oops, hang on a second. Sorry about that. In fact, they were too early, since the core web service standard, WSDL, was not finished. And when it was published, BPML did not work with it. So BPML was quickly replaced by another language called BPEL that did. And while the graphical notation BPMN remained popular with business for process documentation and improvement, it was not a perfect fit with BPEL for automation. So no longer could BPMN claim what you draw is what you execute. So as a consequence, BPMI.org withered and ultimately was acquired by OMG, which is a real standards organization. That was a benefit. It was not until 2010 that BPMN 2.0 finally gave BPMN diagrams a proper execution language. I had been doing BPMN training on version 1.x since 2007, and so somehow I wound up on the BPMN 2.0 task force defining the standard. Later, OMG developed two companion business automation standards, CMMN for case modeling and DMN for decision modeling, all based on the same basic set of principles. So why is there not a single standard? There are three standards because they cover different things. They were developed at different times for different reasons by different groups of vendors. So let me briefly describe them, what they do, and then we'll discuss why they remain important today. BPMN was the first. BPMN describes a process as a flowchart of actions leading from some defined initial triggering event to one of several possible end states. Each action, rectangle in the diagram, typically represents either a human task or an automated service, unifying human workflow and EAI in a single process model. That was new. The flowchart contains numerous branching paths, but every instance of this process must follow some path drawn in the diagram. And that's both its strength and its basic limitation. BPMN remains very popular today because the diagrams are intuitive, users understand them in general terms without any training, and what you draw is what you execute. BPMN can describe many real-world processes, but not all of them. There are actually two distinct communities of BPMN users. And it's interesting that they interact rarely, hardly at all, actually. One uses BPMN purely for process documentation, description. They have no interest in automation, just for documentation and analysis. Those BPMN users simply want to document their current state business processes with the hope of improving them, since the diagrams, especially if made with something like method and style, more clearly express or describe the process logic than a text document. For them, the value of BPMN is it generally follows the look of traditional swim lane flowcharts, but now with standard shapes and semantics. The other community of BPMN is interested in process automation, the actual implementation of new and improved processes. For them, the value of BPMN is, the value is what you draw. What you draw is what you execute. Excuse me, I'm losing my voice already. Since the diagram is aligned with the execution language, BPMN is what allows business teams to better specify process requirements and generally collaborate with the development teams more closely. This reduces time to value and generally increases user acceptance. So as a provider of BPMN training, my interactions have been mostly with the first community, but in an earlier life as an industry analyst, they were exclusively with the second community. So I have a good sense of the expectations of both groups. And while I believe that the descriptive modeling community is probably still larger, it is now declining relative to automation. And here's why. In a descriptive modeling team, there are typically meetings and workshops. You're probably familiar with these, where the facilitator asks, how does the process start? What happens next? And so forth. And that's good for capturing the happy path, the normal activity flow to a successful end state, which is the main interest. But BPMN diagrams also contain gateways and events that define exception paths. Since remember, every instance of the process must follow some path drawn in the diagram. Even so, in reality, you're never going to capture all the exceptions that way, especially the most problematic ones. So over the past decade, a lot of process improvement efforts have shifted away from descriptive process modeling in this way to something called process mining, instrumenting key steps of the process as it is actually running, however they're achieved, and correlating the timestamps to create a picture of all the paths from start to end that actually occur, including, importantly, the small fraction of instances that take much too long, cost way too much, and are responsible for the complaints to customer service. Dealing with those cases is what leads to significant process improvement. Some process mining tools try to map the result back to BPMN, but BPMN demands a reason, some data condition or event to explain each divergence from the happy path. So most process mining tools don't do that. And this points to another weakness of BPMN as an automation language, the difficulty in accommodating all the weird exceptions that occur in real-world scenarios. Something more flexible is needed. On the other hand, the process automation segment of BPMN continues to grow. One reason is that automation models now combine BPMN with CMMN and DMN, allowing them to expose more of the logic, events, and decision logic, for example, to the business teams through diagrams and low-code expressions. And another reason now emerging is the ability to generate models and model components with natural language using AI. A bit more on that later. Okay, so CMMN. CMMN was created to handle those processes that BPMN cannot. It focuses on a key difference from BPMN, in particular, work taking an unpredictable path over its lifetime, emphasizing event-triggered behavior and ad hoc decisions by knowledge workers. A case in CMMN is not described by a flowchart, where you can clearly visualize the order of the actions, but rather a diagram of states called stages, each containing tasks, actions, that is, that may be performed or in some cases must be performed in the stage in order to complete the stage and transition to some other state. And this allows tremendous flexibility, a better way than BPMN, in fact, to handle many real-world scenarios in which it is impossible to enumerate all the possible sequences of actions needed to handle the case. This comes at a cost, however. While what you draw is still what you execute, what you draw is not easy to understand. CMMN diagrams are not flowcharts, but state diagrams, and not especially intuitive, especially to business users, even if you understand the shapes and symbols. Each shape goes through various life cycle states: available, enabled, active, completed, or terminated, and each change of state generates an event that triggers transitions to another task or stage. So in the end, the diagram, when fully expanded down to individual tasks, shows actions that may be performed or must be performed, and the events that trigger other shapes. In practice, however, CMMN is almost always used in conjunction with BPMN, as the actions described, involving a mix of automated services and human interaction, are best modeled as BPMN processes. So typically, in a business automation solution, CMMN is at the top level, where the choice of actions to perform is flexible and event-driven, and many of the CMMN actions are modeled as process tasks, meaning enactment of a BPMN process, where you can actually tell what's going on. Organizing the solution in this way has the benefit of CMMN's flexibility to handle the events and exceptions of real-world scenarios, combined with BPMN's business understandable automation of the details of the required actions. Okay, so here's an example taken from my book, CMMN Method and Style, based on a social care services scenario in a European country. Here, the stage active case, that's the large octagon there, contains 4 substages without any entry conditions. That means they can be activated at any time. The triangle marker at the bottom of a task or stage means manually activated. Without that, they would activate automatically. And notice that within each stage are a mix of human tasks with the head and shoulders icon and process tasks with the chevron icon. At the bottom, there are 4 more tasks, not in a substage, that deal with administrative functions of the case. They potentially can occur at any time when active case is in the active state, but they have entry conditions. Those are the white diamonds on the edge, meaning they must be triggered by events, either a user interaction or a timer. And this diagram does not include any of the file item events. That's receipt or change of some document or data, which also triggers tasks and stage entry or exit. So as you can see, CMMN is very flexible. Almost anything could be started at any time, but at this level, it's not revealing as to the details of the actions. Those are detailed within the BPMN processes and tasks. So here's another CMMN example, actually came from Flowable, that illustrates the flexibility for what seems like a simple thing like creating a user account in a financial institution. Yet, yes, that's a straightforward process, BPMN, but it lives inside a wider context, which is managing the user's status as a client. A new client has to be initialized, that is set up. That's another BPMN process. And after that, you can add 1 or more accounts, but just as long as the client remains an active user. So you can deactivate the user. That's another process which automatically terminates the manage active user stage, that's the black diamond on the edge, and triggers the manage inactive user stage, that's the link to the white diamond labeled exit, being the life cycle event associated with the terminated state of manage active user. The only thing that happens in manage inactive user is you can reactivate the user, another process. And when that is complete, since there's nothing else in that stage, the stage is complete, meaning the link to the white diamond in Manage Active User labeled complete triggers activation of that stage. Complicated, right? The hashtag marker on both stages mean after completion or termination, they can be re-triggered. Without that marker, they could not. And finally, the process task delete user has no entry conditions. So it could be activated at any time manually, and when complete, terminates the case, the black diamond. So it seemed like a simple process initially. Add user account in the real world expands to a case handling the whole life cycle of that client. It's visual design. What you draw is what you execute, but the logic is complicated, and the drawing is not at all intuitive. All right, moving on to DMN. DMN describes not actions, but business logic, understandable by non-programmers, but deployable nevertheless as an executable service. DMN is a successor to business rule engine technology from the 1990s, but better aligned with today's microservice-oriented architectures. In DMN, a decision service takes data in and returns data out. It takes no other actions. Like BPMN and CMMN, design is largely graphical. In the diagram you see here on the left, called a decision requirements diagram, it shows the dependencies of each rectangle representing a decision on the supporting decisions and input data connected to it via the incoming arrows called information requirements. The value expression of each decision can reference only those direct information requirements. Even if they're unable to model the value expressions themselves, business users are able to create these decision requirement diagrams, which serve as verifiable business requirements for the executable solution. But DMN was actually designed to let non-programmers go further, all the way, in fact, to executable decision services. Instead of program code, DMN provides standard tabular formats called boxed expressions. These are what define the expressions and compute the value of each decision. Decision tables, like the diagram at the left, are the most familiar boxed expression type, but there are many more, such as contexts, like the one on the bottom right, where rows of the table define local variables called context entries used to simplify the expressions used in subsequent rows. Note here that the value expression of a context entry, such as loan amount, can itself be a context or some other box expression. The expressions in each context entry, these cells in the gray parts of the diagram here, excuse me, the expressions in the gray area use a low-code expression language called FEEL. Although the FEEL language is defined in the DMN spec, it can be used in BPMN and CMMN as well. The combination of DRDs, boxed expressions, and FEEL means business users can correct directly executable decision logic themselves without programming. In BPMN and CMMN, graphical design is limited to basically an outline of the process or case logic, the part shown in the diagrams. To make the models fully executable, those standards still require programming. And I want to say a little more about the low-code expression languages such as FEEL, the low-code expression language defined by DMN. When BPMN and CMMN were developed, they did not define an expression language because they assumed correctly at the time that the details of system integration and user experience would require programming in a language like Java. But DMN was published 6 years later, when low-code tools were much more advanced. DMN was intended to allow non-programmers to create executable decision services themselves using a combination of diagrams, tables, and a standard low-code expression language. An expression language is not a full programming language. It does not define and update variables. It just computes values through formulas. For example, the formulas ribbon in Microsoft Excel is an expression language. So while adoption of FEEL as a standard has admittedly been slow, even within the decision management community, many business automation vendors have implemented their own low-code expression languages with the objective of further empowering business teams to collaborate with developers and solutions. That's a good thing. Low-code expression languages should be seen today as the important other half of model-based business automation, along with diagrams composed of standardized shapes, semantics, and operational behavior. The goal is faster time to value, easier solution maintenance, and improved user acceptance through close collaboration of business and development teams. Now, 3 key principles underlie all of these OMG standards, which play a central role, as I said, in Flowable's platform today. And I want to talk about why they're important. The first is that they're all model-based, meaning diagrams and tables. And those models are used both for outlining the desired solution, what I've been calling business requirements, and creating the executable solution itself. The traditional method of text-based business requirements is a well-known cause of project failure. Instead, models allow subject matter experts in the business to create an outline of the solution in the form of diagrams and tables that can be verified for completeness and self-consistency, unlike text requirements. Moreover, the shapes and symbols used in the diagrams are defined in a spec. So the models look the same and work the same in any compliant tool. And even better, the execution semantics of the shapes is also spelled out in a spec. So what you draw actually is what you execute. Engaging business users together with IT from the start of the project speeds time to value and increases user acceptance. Second, the models can be serialized in a standard XML file format. That means they can be interchanged between tools without any loss of fidelity. In practice, for example, that means that business users and developers can use different tools and interchange models between them. I've been involved in engagements where the business wants to use modeling tool X and IT in a separate organization insists on using tool Y for the runtime. That's not ideal, but it's doable since you can interchange the models between the tools using the standard file format. Oops. There we go. And third, OMG procedures ensure vendor neutrality. Proprietary features cannot be part of the standard, and the IP must be free to use. In practice, this tends to result in open source tools and lower software cost. It may not be widely appreciated, but many, possibly the majority of BPMN diagramming tools today stem from an open source project many years ago. And another open source project, which I believe some Flowable people were involved in created a popular BPMN runtime. DMN is a similar story. Tool vendors were stumped by the challenge of parsing feel, where variable and function names may contain spaces, until Red Hat made their field parser and DMN runtime open source. So implementing these standards is difficult, admittedly, and open source software has been a big step in encouraging vendor adoption. Okay, so where is the business value of these standards? What are the benefits to customers? In my view, these fall into three categories. First, common terminology and understanding. I remember the days of workflow automation before BPMN. There was no common terminology. You learned one particular tool, and tools were for programmers. Now, BPMN, CMMN, and DMN all provide tool-independent understanding of processes, cases, and decision logic. There is a much wider availability of information about these technologies through tool-independent books, websites, and training, down to the details of modeling and automation. And this, in turn, makes it easier to hire employees and engage service providers already conversant and experienced in the technology. It also lowers the relearning cost if it becomes necessary to switch platform vendors. Benefit number two is faster time to value. And today, this is probably the most critical one for customers. Model-based solutions are simply faster to specify, faster to implement, and faster to adapt to changing requirements than traditional paradigms. Faster to specify because you can more easily engage the subject matter experts upfront in requirements development, and more quickly verify that the requirements are complete and self-consistent. Faster to implement because you're building on top of standard automation engines. The custom code is just for specific system integration and user experience details. And faster to adapt to changing requirements because often this involves only changing the model, not the custom code. So for example, a healthcare provider can go live with a customer onboarding portal in only 3 months instead of a year, leveraging involvement from business users across multiple departments and close collaboration between business and IT. Everyone is using the same terminology, the same diagrams, even if they're using different tools, and what you draw is what you execute. A key feature of the three OMG standards is they were designed to work together. CMMN, for example, has a task type that calls a BPMN process and another that calls a DMN decision service. A BPMN task can call a DMN decision service, and on some platforms also a CMMN case. And so you have platforms like Flowable that handle the full complement of business automation requirements: event-driven case management, straight-through process automation, long-running process automation, and decision automation. The alternative to this is a lot of custom code, expensive, hard to adapt to changing requirements, or separate platforms for process, decision, and case management. Again, expensive and requiring a lot of system integration. A single platform that handles all three, especially one based on models, on business engagement, and vendor-independent standards, lowers costs, the cost of software, of implementation, and of maintenance of the solution over the long term. Okay, so these standards are 8 8 to 14 years old, not new. And today, all the excitement is about something totally different, generative AI. Generative AI is software trained on large language models, you know that can generate text, images, audio, video, and code based on specific context and user requests called prompts. Technically, you could say it has nothing to do with CMMN, BPMN, and DMN, but it can add value to business automation projects based on those standards. Here are a couple ways it can do that, both at design time, what Flowable calls smart modeling, and at runtime. First, smart modeling. Well, I've mentioned the value of a single platform for solutions that combine CMMN, BPMN, and DMN. We need to remember that these are three different languages. They create different artifacts and handle data slightly differently. So the solutions have a lot of different pieces. And putting them together is not too difficult, but it's time consuming. So on the other hand, how they go together in the solution is well understood. Solutions incorporating CMMN, BPMN, and DMN typically have a similar structure. So just assembling the building blocks in a skeleton of the solution is something generative AI can do. Suppose your prompt asks AI to create a skeleton model of an order-to-cash process using CMMN, BPMN, and DMN. From its large language training, it knows what the elements of order-to-cash are, the various tasks and data elements required, and if you provide it additional context in the way your other automation solutions are structured, it can organize those elements the way you would normally do it in a hand-built solution. It can create skeleton BPMN, CMMN, and DMN models and the links between them. It can create forms to enter or display the data used in various parts of the solution. If your context includes existing services that might be used in such a solution, it can use those as well. Or you could instruct it to do so in your prompt. So something that might take a developer days, weeks, can be returned by AI in less than a minute. You've given AI a request in natural language and it returns code, a first draft of your implementation. At runtime, AI can assist or even replace human task performers. We've all had interactions with chatbots that aren't very smart. Pretty soon, we're screaming to be connected to a person who can actually understand and maybe help us. Generative AI can turn dumb chatbots into smart ones that understand what you would like to do, collect the information needed by the processes that can make that happen, and initiate those processes automatically. And it can assist customer service reps in the same way, speeding up the interaction and automating the required actions. Also, a well-known strength of generative AI is summarizing complex information. Excuse me. While understanding the current state of a single BPMN process is straightforward, understanding the current state of an active case is not. There are very many tasks to be performed in various parts of the case. Which ones have been done? Which are required but not yet done? Which are the critical ones affecting completion of the case. While you can query the runtime for these things, it might be simpler to ask AI to summarize the current state of the case. And in your prompt, you can specify particular items of interest. It's easier and faster that way. I have no doubt that Flowable will be talking about, maybe demonstrating AI capabilities, things such as these at FlowFest, things that are creating a new generation of model-driven business automation based on these standards. So 3 standards working together to make business automation better specified across business and IT, more integrated, lower cost, faster time to value, and now augmented by generative AI. All key underpinnings of the Flowable platform. So thank you for your attention.